All right, so back to recording and everything else, because I was playing fast. When two chords intersect inside the circle, would be a picture like this. Two chords are intersecting inside the circle. Now, when they do this, each chord is cut into two segments. So the segments of the one piece we'll call A and B. The segments of the other piece we'll call C and D in length. And what we are going to be proving here are given as the diagram, by the way. What we are going to be proving is that A times B will equal C times D. Bill is out there.
Oh.
The janitor's working on something. I have no idea. Now, what we want to prove here looks like we need similar triangles, a proportion, and then this is a means extremes property for a proportion. So what we need is similar triangles, which means I'm going to need to draw some auxiliary lines. Shit yourself. All right. Does it look like we're recording now?
Yeah.
So our auxiliary lines we'll put in green here. We need to have a couple of triangles that are similar triangles, and in fact, they need to have a vertex at that point so that these are sides of the triangles. So my triangles are going to have these two auxiliary lines forming them. Now, the question would be, why are these triangles similar triangles? And what I can look at is inscribed angles that intercept this arc. Are there two inscribed angles there that intercept that arc? There is this inscribed angle that intercepts that arc, and there is this inscribed angle that intercepts that arc. From Corollary 1 of Theorem 9, what is that theorem? 7? 9-7. From Corollary 1 of Theorem 9-7, if we have two inscribed angles that intercept the same arc, they have to be congruent. Now, we also have the vertical angles that we know are congruent. All we need in two triangles to prove that they are similar is two pairs of congruent angles. So, by Theorem 9-7, Corollary 1, two inscribed angles that intercept the same arc are congruent. That's arc, and this is R. Congruent. Since the vertical angles are also congruent, these triangles are similar, so corresponding sides will be in proportion. So the triangles are similar by angle-angle similarity.
Really? was him. I'm trying to write. He's doing that.
He started. He started. See that? I had to deal with it. Wait. He said,
He is.
no,
Okay, now can you pay attention?
Now our corresponding sides, C goes with B because they're both in between the marked angles. C will be to B as, and I have to be careful to have sides from the same triangle on top. So C is on the smaller triangle, A is also on the smaller triangle. This will be as A is to D.
Did you?
Okay,
What's National Honor Society?
now when I continue here, the means extremes property is your cross multiplication property. And the cross multiplication is what we want to prove. A times B equals C times D. All right. Moving now to Theorem 912. Theorem 912. When two secant segments are drawn to a circle from the external point, the product of one secant segment and its external piece will equal the product of the other secant segment and its external piece.
I forgot what's a secant.
It is a line that contains a chord. So it's what happens when you extend a chord beyond a circle.
Oh.
Could you put the connection chord with this?
Oh, that's what it is.
So here we have a couple of ideas we need to talk about. What does it mean when it says the external piece? And what does it mean when it says the secant segment? So if we have two secants drawn to a circle from a point, first off, the secant is considered to be the length from the point to where that secant goes through the circle to the other side. Between those 2 points is the length of the secant. So we're going to call that length S, and to show that we're talking about that length, we'll do that type of thing. Okay, S. Could you please not be doing other things besides this? I know. Could you do one thing only, and that is try to pay attention?
It's hard.
I know, but can you try that?
He's cheating for us.
Okay. Now,
Now,
back here.
yeah.
The external segment then is the distance between this first point on the circle and that point. So we're going to call that length T. So again, T comes between these 2 points right there, and S is that whole segment. Now, talking then about the other secant, we're talking about the whole secant as being the distance between these 2 points. We'll call that U. And then the external segment of that secant would be the distance between those 2 points. We'll call that W. Okay. Now, the given is the diagram. And what we want to prove is that S times T equals U times W. Again, we're going to need some auxiliary lines so that we have 2 triangles. And we want these pieces to be parts of the 2 triangles. So my auxiliary lines are going to be this line that connects those 2 points and this line that connects those 2 points. And the question then would be, why are the triangles similar? Because again, it's going to be because of similar triangles. Are there 2 inscribed angles that intercept that arc? This angle is an inscribed angle that intercepts that arc, and this angle is an inscribed angle that intercepts that arc. I could label these angles so we could refer to them, or I could just talk about it. Is there an angle in both triangles now that is shared? Is there a shared angle in both triangles? This angle right here is a shared angle in both triangles. So the triangles have to be similar by angle-angle similarity. So, because there are 2 inscribed angles that intercept the same arc, and because the 2 triangles share an angle, and I wasn't really clear about what 2 triangles we're talking about. One of the triangles would be this triangle here. We'll make it bright yellow. We'll make it bright yellow. And the other triangle is this triangle here, if I can draw a nice straight line. that triangle there. Okay? Those two triangles have an inscribed angle. I'm going to erase this side here because I don't need it. And they share an angle. Okay. Maybe I can move that up there again. There we go. So the triangles are similar. By angle similarity. Now we can say the ratio of corresponding sides will be in proportion. And our corresponding sides in the green triangle, T corresponds to W in the yellow triangle. And then in the green triangle, U corresponds to S in the yellow triangle. Now it means extremes property. So when we cross multiply here, we get what we want to prove, that S times T equals U times W. Theorem 913 now. Theorem 913, when a secant segment and tangent segment are drawn to a circle from an external point, then the product of the secant and its external segment will equal to the square of the tangent.
Oh, that'd be so cool. Oh,
I
get
think
so many more.
a bit more expensive, it's quite a bit more expensive.
Yeah.
No, it seriously would be very awesome. You're right. Because then you wouldn't have this third program to go through.
That's what you know. Yeah, really. Yeah, you get to find
Okay. Now, the diagram. We have a secant and a tangent. The secant is referring to the distance between those 2 points. So if we call this length W, and this length U, the length U comes from this point to that point. Then the length of the tangent comes from the point of tangency to that point. That length is going to be called T in this case. And what I want to prove, again, my given is just the diagram. What I want to prove then is that W times U will equal T squared. Again, we're working with similar triangles and proportions. So, to discover what are those similar triangles, we're going to be working with these 2 segments. And my 2 similar triangles are going to be this triangle here and this triangle here. Those are going to be my 2 similar triangles. Now, first off, there is an angle that is shared in those 2 triangles. We're looking at the green triangle and the blue triangle. The angle that is shared is this angle right there. Second thing, we have 2 angles that are half of this arc, but for 2 different reasons. I'm going to change the color of that arc to bright yellow. Did you get it? Yes. My first angle that's half of that arc is this angle because it's an inscribed angle. The second angle that's half of that arc is this angle because it's an angle formed by a chord and a tangent. So I'm going to change these to yellow so that they look like they're related to that arc. Okay? Each of those yellow marked arcs is half of that yellow arc. So, now what we have is 2 similar triangles. Now I know I wasn't very fair to you because you can't use color there very well. But what I have here is that the yellow marked angles are each half of the yellow arc. And that'd be by theorem 9.7 and 9.8. Then the double marked angle is an angle shared by both triangles. So the triangles are similar which means corresponding sides are in proportion. Okay, since corresponding sides are in proportion, this is the proportion we can form. You'll notice then in each of the triangles, the blue and the green, W in the blue and T in the green are in corresponding positions in the triangles. So W will be to T as. Now, looking for another side in the blue triangle. W is in the blue, another side in the blue. Okay. Another side in the blue is T. Now, the side that corresponds to T, that is in the green triangle, is U.
B?
Yes, U.
Store cookie.
Okay, now using our means extremes property gives us what we want to prove here, which is W times U equals T times T. Okay, now on these diagrams, what I've been wanting to get to is a recap where we recognize we have several pieces of information about these diagrams that we know. First off, if there are two chords that intersect in the diagram, we know something about the angles. The angle is 1/2 of the sum of these arcs that are inside the angle. No, I'm just trying to keep all of your attention. All. As in 1, 2, 3, 4, 5, 6, 7, 8 of you.
9.
I have my attention. Okay. So now.
I'm going to pay attention.
Keep your attention. So.
I'm going to pay attention.
Okay. Thank you. No.
We'll be through that.
What we know about x is it's 1/2 the sum of y and z. We also know if these are segments A and B, segments C and D, we know that A times B equals C times D. Those are the two things we know about that diagram. Now, if we have two secant segments, we know two things about this diagram as well. If I can manage to get things so that they connect.
Yeah, no. Oh, it's not touching it yet.
Okay. Because I can. Okay. What we know is that the angle, which let's call x, and if this is y and z, the angle x is 1/2 the difference of y and z.
I'm laughing at him.
The length of the segment we know something about as well. If we refer to this length right here, from the end of the secant to the point, as A, and this as B, and this other secant from this end to the point as C, and this length as D, we know that A times B equals C times D. Now we have two other diagrams to look at. Our two other diagrams deal with secant and a tangent and two tangents. So, first diagram, let me make this one smaller too. Okay, if we have a secant and a tangent, we know again the two things about this diagram. We know that this angle is 1/2 the difference of y and z. And we know that the lengths of the segments, if this length is A, and this length is B, and then the tangent is T, we know that A times B equals T squared. The next worksheet we're going to be working with,
You see that? That's what they're doing to us. They keep throwing
See what they're doing though? They were harassing me.
What?